up to now, we've only done angles between 0 and 90 degrees for trig, because we've only been working inside right-angled triangles, where these angles need to be acute. Alright, we can extend the meanings of the trig ratios to the Cartesian plane, which can extend the angles to 0, between 0 degrees and 360 degrees. So if we consider a circle with center 0, 0 and radius r, that means that the center of the circle is at the origin and the radius has a distance of r. And the point r, or the coordinates r, which is x and y, any point on the circumference of the circle. Then theta is the angle measured from the positive x-axis, which is this here, this is the positive x-axis, to the radius of the arm. That would be the radius, which we call OR. Right, it's also called the terminal arm. Right, but the radius doesn't just have to be here. Obviously here the angle theta is acute. But if we draw the radius, let's say here, and we're still measuring from the positive x-axis to the radius, anti-clockwise, that would be theta over there. Now it is greater than 90 degrees. Similarly, we can have it over here or over here, alright, and measure from there around or from there around. Alright, and all of these would have different points x and y on the circumference. Now if we just focus on this over here, this combination over here, it's easy to explain. If I draw a dotted line down here that's perpendicular to the x-axis, I formed a right-angled triangle. Then this distance over here is the x value, the distance, how far it is from the origin. And this distance over here is the y value, in other words, how tall it is. Alright, so we have an x value and a y value, and even if you draw your triangle here, this is r, this is x, and x will be negative, and this is y. Or if you draw it over here, this would be x, this would be y, and this would be r. Or if you draw it here, then you have an x value and a r value and a y value. Right, now remember, in a right angle triangle, in any right angle triangle, if this is x and this is y and this is r, then the hypotenuse squared is equal to one of the sides squared plus the remaining side squared. So for any r value on our Cartesian plane, the radius squared is equal to the x value squared plus the y value squared. Alright. So for each r value on the terminal arm of theta, the following functions of theta are defined. Now up to now we've worked with SO, CA, TOA, which only worked in this quadrant here where the angle is acute. Alright, now we can actually do it here. If we have theta over here, we can extend these definitions to greater than 90 degrees as well. If this is r, this is x, and this is y, then opposite is y, and adjacent is x, and the hypotenuse is r. So opposite is y, hypotenuse is r. So sine is y over r, and cosine is x over r, and tan is y over x. And this will be true for any triangle here or here as well. Alright? And the way that I remember it is shade your rear, cos x rays, tan your exterior. Sine is y over r, cosine is x over r, and tan is y over x. The Cartesian plane can be divided into 4 quadrants called the first quadrant, second quadrant, third quadrant, and fourth quadrant. And in the first quadrant, x is positive, y is positive, and note r is always positive. Okay? In the second quadrant, x is negative, y is positive, and r, because it's the distance of a radius, is always positive. In the third quadrant, x and y are both negative, but r remains positive. And in the fourth quadrant, x is positive, y is negative, and r is positive. We can also measure here, it goes from 0 to 90 to 180 to 270 to 360. So in total it makes a circle. From 0 to 90 is the first quadrant, from 90 to 180 is the second quadrant, from 180 to 270 is the third quadrant, and from 270 to 360 is the fourth quadrant. Right. So let's consider the values of sine, cosine, and tan in each of the quadrants, and I've already written them down so that we can just check. In the first quadrant, sine is always y over r. We said that x, y, and r are all positive. So y is positive and r is positive. Positive divided by positive is positive, so sine is going to be positive. For cosine, x is positive and r is positive, and that will give us cosine, which is positive. Similarly, y is positive and x is positive. That's going to give us positive. That means that all the ratios are positive in the first quadrant. Right. Now, for the second quadrant, sine is y over r. Y is positive, r is positive, so sine is going to be positive. X is negative, r is positive, so cosine is going to be negative. Negative divided by positive is negative. For tan, y is going to be positive and x is going to be negative, so tan is also going to be negative. The only positive ratio is sine in the second quadrant. Right, next one. If we look at the third quadrant, y is negative and r is positive. That means that sine is going to be negative. X is negative and r is positive. That means that cosine is going to be negative. Y is negative and x is negative. Negative divided by negative is positive. That means that in the third quadrant, the only positive ratio is tan. Right? And then lastly, let's look at the fourth quadrant. Y is negative, r is positive, so sine is going to be negative. X is positive, r is positive, so cosine is going to be positive. Y is negative and x is positive, so tan is going to be negative. The only positive ratio in the fourth quadrant is cosine. Alright, so this is always true. All ratios are positive in the first quadrant, sine is negative in the second, tan is positive in the third, sine positive, tan positive, cosine positive. That means that everything that's not marked here is going to be negative. Okay, we remember it in this way. We call it the cost table because CAST spell cost. All sine, tan, and cosine. Or you can remember it if you want to go with the quadrants, first, second, third, and fourth. All singers take cough medicine. Right. So as an example, let's just check in which quadrant does the terminal arm of the angle theta lie if the following is true. Sine is negative. Okay. Sine is positive here and here, which means it must be negative here and here. Alright? And then cosine is positive. Cosine is positive here and here. Okay, now we have a few options, but where they overlap, where we have 2 ticks, that is the quadrant that we are working in. So the quadrant that we're working in is the 4th quadrant. Okay, now if we had to draw a triangle in that quadrant, it would look like this. We'll get to that in the next example. Right. 2 more questions from this example. If sine is negative, we already discussed that sine is negative in this quadrant and in that quadrant. And theta lies between 90 and 270. 90 starts over here and 270 ends over there. So it's between 90 and 270 here and here. So together that gives us the 3rd quadrant. Right. If we had to draw a triangle here, it would start in the origin and make a radius with our dotted line there. Okay, last question. Cosine is negative. So if this is the cos table, all singers take cough medicine. Cosine is negative in this quadrant and in that quadrant. Right, and then between 0 and 180 degrees, 0 starts over here, 180 ends over there, so it's either here or there. Together they make the 2nd quadrant. Right, you can practice identifying the quadrants through exercise 7 on page 81.